All right, welcome back for Check Your Understanding. This is topic 8.7 and 8.8. So we have a region bounded by the graphs of y equals x squared minus x squared minus 1, and x plus 1. So you see the line x plus 1 is right there. Let's go ahead and write that next to it. And then this curve is y equals x squared minus 1. So those are our two graphs. Region R is the base of the solid. Each cross-section is perpendicular to the x-axis is a square. So our cross-sections are going to go this way, perpendicular to the x-axis. If you recall, I'm using red again to just kind of bring that back in. We're going to be using a of x. We need to find our intersection points. They're not too hard to find. This one is -1, 0. And this one is 2, 3. If you plug 2 into that, you get 3. If you plug 2 in over here, 4 minus 1, 3. And so those are our two. Again, -1. 1 squared minus 1 is 0. -1 here, 0. So those are the correct intersections. Excuse me. So R is the base of a solid. Each cross-section perpendicular to the x-axis is a square. Find the volume of the solid. Okay. So each cross-section is going to be a square. Now the size of our squares is going to change. So over here, our square is going to be smaller than our square over here. But the length of our side of our square is not going to change. So the area of a square So the area of a square is s squared. And s, this length, this red line, is x plus 1 minus x squared minus 1. Okay. If you want to find out how long something is, how far apart two things are, you subtract. And so that's why we're subtracting over here. So that's our area of one slice. So our interval is going to go from -1 to +2, the x coordinates of our intersections. And then it's going to be our area that we found of one slice, x plus 1 minus x squared minus 1. We're going to have to square that because one side times the other. So I actually did not write that down, but one side times the other side. It's a square. All the sides are the same length. Yes. We're going to let our calculator do the work here. So let that pull up. So going to y equals x plus 1, next x squared minus 1. Okay. And then I'm going to go ahead and quit. I'm going to hit math and 9. My integral is going to go from -1 to 2, x plus 1 in parentheses, close the parentheses, minus, also in parentheses, x squared minus 1, close parentheses. I'm not going to do it this way. That's why I did it here. Alpha trace y1. I do need some parentheses, but y1 minus y2 okay. I need some parentheses there. Parenthesis. Insert parenthesis. Squared x. X. 8.1. Which means it wouldn't have been that hard to integrate if I got a nice clean number like that. It's 8.1. And that's it. So the hard part is setting up. That's always the hardest part. Okay. Okay. So same thing. Region R is the base of a solid. Each cross section is perpendicular to the x-axis is a semicircle. So now my shape is a semicircle. Okay. So I need to know R. So this diameter is the same as it was a minute ago. X plus 1 minus x squared minus 1. Same. Exactly the same. Nothing's changed. But the radius is half of that. So R equals 1/2 of my diameter. Okay, so that's R. Now my formula for the area of a semicircle is, I'm going to write this in red, in the black actually, 1/2 pi R squared. So my integral is going to be, this is going to come in front, pi over 2. So there's my 1/2 pi. Integral from -1 to 2, same thing. Okay. The difference here will be the inside. I will have x plus 1 in parentheses minus x squared minus 1, also in parentheses, all over 2. Now I can either have 1/2 in front or this, doesn't matter. And I'm going to square it, dx. Now I'm going to get a much different number here. Okay, we're going to go ahead and leave pi out when we do this calculation. I'll show you what I mean. Let's go ahead and go back to my calculator. Anyway, math and 9, the integral from -1 to 2 of the same thing, except now it's a fraction. So alpha y equals fraction. And so I'll have y parentheses alpha trace y1 minus alpha trace y2 over 2 close parentheses to the second power dx. And so it should be that part, no big deal. I get a nice clean number. Then I'm going to times that by, just let's use 0.5 first. And then I'll just write pi at the end of my answer. This is equal to 1.0125 pi. Okay. You can also then go approximately equal to answer times pi. .1808. Okay, whatever works better for you. Okay. Okay, next problem, staying with the same R. Same problem. R is the base of a solid. Each cross section is perpendicular axis is an equilateral triangle. Right, but do not solve. So now we have an equilateral triangle instead. So still the same red. Now I have an equilateral triangle. This is quite a bit harder. All the sides are equal. So area of any triangle, area of a triangle, equilateral, any triangle is 1/2 base times height. Now my base is going to be the same equation that I've had for a long, long time. But my height, since it's equilateral, my height will be my base, the red divided by 2. So the base divided by 2 times the square root of 3. Right there. Okay. And again, my base is x plus 1 minus x squared minus 1. Okay. So my integral, same endpoints, will be 1/2 base times height, which is the same thing. So we're a square. We back out here. So it'll be, go back to this equation. 1/2 base times height, base over 2 radical 3, which will become radical 3 over 4, all these numbers, 1/2 to 1/2, that's 4 radical 3 on top, times base squared. So base is getting squared. So up front, instead of this 1/2, I'm going to have radical 3 over 4, negative 2 to 2 dx. And it said right, but don't solve. Right, I'm finished. That parenthesis looks dreadful. Not pretty good. So 1 parenthesis, another parenthesis squared. Okay. So far, a little frustrating. Each region bounded by the same curves, and the x-axis is the base of a solid. Each cross-section perpendicular to the y-axis. So now we're going this way. So now we're going to be dealing with dy. Is a rectangle of height 4. Find the volume of each solid. Okay. So now we're going this way. So we have a rectangle. And this is 4. Okay. Now this may be skinny or tall. I drew it this wide way, the way that it was drawn on the answer key. Was the other way, it doesn't matter. This, now I need to solve both of my equations for, I solve both my equations for x. So this is y plus 1 equals x squared. So x equals square root of y plus 1. We only need the principal square root because it'll work out, which is nice. And then the other equation is x equals y minus 1. So this little length right here is, we're looking at this. This curve is first because it's the furthest away, and the line goes second. So on these, the line was the farthest away. So this happens to be curve minus line. So my curve is square root y plus 1 minus y minus 1. So there's my equation for the length. Okay. So my answer is going to be the integral. Now I'm going to use my same ordered pairs, but now I'm going to use y values. So from 0 to 3 instead of -1 to 2. 0 to 3. The area is going to be 4 times the length times width. Square root y plus 1 minus y minus 1. Okay, dx. dy, excuse me. There you go. Let the calculator grind on that one for a while. So I have math 9 from 0 to 3 of 4 parentheses root y plus 1 and square root minus parentheses y minus 1 close parentheses, close the other parentheses, dx, dy. Yeah, there you go. We've got 12 2/3. There you go. And that's it. I did neglect to write over here that the area of a rectangle is equal to base times height. So, or length times width, whatever. Same idea. Okay. All right. I hope that was helpful. We'll see you guys soon.